Hi everyone, good morning. Welcome to my project for CS221. My project is called State Space Model for Improving Gender Bias in AI. As we know that there is gender bias which is prevalent in AI system because of the data that they are trained on. I wanted to work on this project to introduce a new method, a new approach using hidden Markov models to detect these biases and reduce them. So the dataset that we are using for this project is called Bias, which is a well-known benchmark for evaluating gender bias, especially the type 1 anti-configuration, which contains prompt designed to test bias in gendered occupations, such as associating nurse with she and engineer with he. This dataset contains 790 sentences, each containing co-references between nouns and pronouns that the model must resolve. After collecting the data, I processed it by extracting relevant sentences and co-reference clusters, which are essential for understanding how the model associates pronouns like he, she, they with nouns in the sentence. We then will pass it for the baseline, we will pass it through Mistral 7B to evaluate its bias in terms of both pronoun usage and context alignment. The processing involved ensuring that the data was appropriate, clean, and formatted. So, for example, if you take a look at this example, the teacher gave the student a book because she was kind. This is the input sentence, and we will ask Mistral 7B to kind of resolve it. And please resolve the co-references, and the output of the model will be like this. The pronoun she refers to the noun the teacher because it is the only noun in the sentence. So this is what the model will respond. Now for the baseline, we passed it through 7B. All the 790 sentences got the response with the answer. Now the baseline metrics we will calculate. There are four metrics that I focused on here. The first is the gender bias score, which measures the extent to which model uses gendered language. Context alignment measures how well the model's response matched the expected gender. Stereotype score indicates how much the model reinforces or avoids stereotypical gender. Pronoun distribution tracks the frequency of different pronouns used, including gender neutral ones. Like I mentioned, the approach, we got the baseline, and after that, we will introduce the hidden Markov model integration. In this, we will use hidden Markov model to adjust the outputs dynamically. The hidden Markov model help us to understand the transition between states. That are three states that are defined, that is neutral, biased masculine, and biased feminine. The idea was to analyze the model output sequences when we could identify which state the model's output belonged to and the transition to a more neutral state if bias was detected. The features that were used were stereotype score, pronoun counts, and sentiment score. Using these features, I trained the HMM on the dataset where the model learns the probabilities of transitioning from one state to the other, for example, from biased male state to neutral. Now, before going on to GPT, let's take a look at what was the result. For the gender bias score with the baseline, we got a minus 0.25 score, which indicates a male bias. For the context alignment, we got 25% of the baseline were contextually aligned. For stereotype score, we got around stereotype was 1. So after we introduced the hidden Markov model approach, you can see the difference. So from minus 0.25 it came to 0, and the context alignment from 25 it come to 65, and then stereotypical score was 0. So this is indicating that our hidden Markov model approach was very useful and improved the result significantly. So here also I have signified the result improvement. Now the other thing that I wanted to use was, I wanted to see that if I pass the model's output through GPT, then does it even further refine it. This is also all done for fine tuning it. So when I passed the model's result to GPT and asked it to improve it, it showed further improvement. So the gender bias actually increased to 0.05, and the context alignment improved to 70%, and the stereotypical score reduced to 0.02. So if we compare, you can see that the results for all of these are shown here. So the baseline are these, and then the adjusted with our hidden Markov approach was this, and then this is the final approach. So if we have to compare all the three approaches, this is a table which graph which kind of improves, shows the improvement. The gender bias score from minus 0.25 to 0.02 to 0.05, the context alignment from 25 to 65 to 70, and the stereotypical score also improved significantly. These are some other metrics which I have also shown in the code if you want to refer through. I have addressed all the code and everything inside the GitHub link that I have provided, so feel free to check it out. There are some ethical consideration also that I wanted to mention, that the bias in AI system is wide reaching, especially when it comes to decision making in the fields of hiring, law, and reinforcement. So if AI system exhibit gender bias, they could reinforce societal inequalities, which is why this project was very special and important to work on. And my hope is that there is no further inequality or gender bias in future AI systems. Thank you. Oh, also to conclude,